Hello to everyone. Thank you for joining us tonight. I'm Hunter with the Swanner Preserve and Eco Center. I'm just going to take my mask off for the quick part of the presentation. I'll make sure to give everyone lots of space. And we're so glad to have all of you with us, all of you joining us online and a couple of you joining us here in person. Tonight, we're going to talk about microplastics. The Snyderville Basin Water Reclamation District has been doing some really cool research based on the microplastics here in our water. So we're excited to hear about that from Mike. And tonight's presentation is part of Think Water Utah, which is a large statewide conversation on water. And so part of that also is our new exhibit, Decisions Downstream, which is at the Eco Center right now. And that's created by Sarah Null, who's a watershed scientist, and also a few local artists. So it's all about how river habitats are being impacted by water development decisions and how we can make creative new water development decisions to help keep water in our streams, but also get water to our people. I'd also like to thank Summit County RapTax and Think Water Utah for sponsoring programs like this. This program is part of our Walks, Talks, and Workshops program, which happens a few times every month and focuses on environmental and natural topics. So we're really excited to talk about microplastics in the waterway. And the last thing is I'm going to introduce Mike. So Mike Luers is going to be our presenter this evening. And we're excited to have him. We always love working with you guys. He's the general manager here at the Snyderville Basin Water Reclamation District and has over 40 years of experience in wastewater treatment and facilities. So I'll pass it off to him and let him give you the rest. I think your mic is all good to go. Your mic is not working. So,
okay. How about that? So my name is Mike Luers. I'm the general manager of the Water Reclamation District. I want to thank everyone for attending, and certainly want to thank the Swanner Nature Preserve for inviting us here at the Water Reclamation District to give a presentation on some of the work that we've been working on. So tonight we're going to talk about microplastics, and it's a complex subject. So I'm going to jump right in and say that we're going to start out by defining what microplastics are. Then we're going to talk about why they might be an issue and what we know, what we don't know about them, and then where microplastics are originating here locally and how they get in, and how they're getting into our environment, and then answering the questions that you may have. So let's talk about plastics. What is plastics? So plastics are compounds that are formed from basic elements, and it's kind of like Legos. You take a little bit of carbon and you add a little bit of hydrogen, a little bit of oxygen and nitrogen, and the combination of organic plastic molecules is endless. There are thousands and thousands of different types of plastics, and all you have to do is add another little Lego block and you have a new plastic. So it's not like there's only a certain limited number of plastics. So let's talk about what a microplastic is. Most folks think of a microplastic as a small piece of plastic that's derived from a larger piece of plastic, and that's correct. But we have a definition for microplastics, and it pertains to the size of the piece of plastic. So we generally refer to microplastics as a piece of plastic that's about 5 millimeters in size down to 1 micron. So that would be about the size of an eraser down to 1 micron, which is pretty small. And a micron is about the size of the particles in cigarette smoke. So it's pretty doggone small. And if you compare a micron to some of the things we're associated with each day, you see that a micron is smaller than a red blood cell, way smaller than something you can see. Cigarette smoke is way smaller than forest fire smoke. So they're pretty doggone small. Now, in addition to what we call microplastics, we have nanoplastics. And those are pieces of plastic that are even smaller. So a nanoplastic is from 1 micron down to 1 nanometer. Now we're getting really, really, really small. A little picture of DNA there illustrates that DNA, that stuff that we have in our cells is 2 nanometers wide. So it gives you an idea how small it is. Another way of thinking about nanometers is our fingernails grow about 1 nanometer per second. So really, really small. And a piece of paper is about 100,000 nanometers thick. So think of a piece of plastic that's that small. That's what a nanoplastic is. Kind of a third category is what we call micro rubber. And these are small pieces of rubber that generally originate from the wear of tires on our local roads and roads all over the world. A typical passenger tire is made up of about 19% natural rubber coming from a rubber tree and about 24, 25% of synthetic rubber. And that rubber is a type of plastic. So micro rubber is a plastic, and we refer to it as a plastic. Tires are made, in addition to the natural rubber and the synthetic rubber, many, many different types of additives. And it's quite complex when you look at the chemistry and trying to decide if the micro rubber is causing some type of environmental problem. So for discussion purposes this evening, I am going to use the term microplastic to represent microplastics, nanoplastics, and micro rubber. So, you have your microplastics from 5 millimeters down to a micron, and your nanoplastics from 1 micron down to a nanometer, and then your real small micro rubber. So when we talk about microplastics, there's different shapes and forms of microplastic. So here you have fragments, which is what you would expect a microplastic. It's a small piece of plastic that broke off of a larger piece of plastic. Now you have fibers, which comes from clothing, and you'll hear me talk a great deal about that this evening. You have foam coming from like food containers. And then you have nodules or nodules that are used in manufacturing, and we don't see that are in our local environment. And you might see micro beads. Some face washes, as an example, you feel little beads in there. At times, those are pieces of microplastic. So where is all the plastics coming from in our local streams and oceans? The percentages are about the same. The largest portion of microplastics is coming from synthetic textiles, clothing, and we'll talk about that. The next is car tires, that micro rubber I talked about. And then you have city dust, which is an aggregate of all the little bits of plastic that kind of wash out of a city through the stormwater system. And this might be rubber coming from your shoes. It may be that plastic bag that's blowing down the road and abrasion is breaking little pieces off. Many, many, many different sources of plastic in a city. And then you have a few other minor sources. But to say that the vast majority comes from clothing, tires, and then city dust is what we really need to pay attention to. Why are microplastics an issue? Microplastics are everywhere. Everything we drink, we eat, we breathe has a potential to contain microplastics. When studies are done of fecal material coming out of people, everyone has microplastics that they have consumed that they excrete. It just gives you an idea of how many microplastics are in our environment. In addition to that, a good number of the most toxic chemicals that EPA regulates, heavy metals and some organics, are either on or in microplastics. And I'll talk a little bit more about that in a minute. Now, in South Carolina, they wanted to know where the microplastics were coming from along their local roads. So they went to, I think, 7 different stormwater retention ponds along the side of the road, which we have many of here in the Park City area. And they took samples, and they found out that about 80% of the microplastics in each one of those storm retention ponds was coming from tire wear, micro rubber, which is kind of what you expect along a road. But It just goes to show that micro rubber, which is a subset of microplastics, as I indicated, is of importance to the environment. Now let's talk about microplastic toxicity. There's a couple areas that we need to discuss. So when would a particular type of microplastic become toxic? Well, first of all, it has to do with the size of the microplastic. You know, we talked about the microplastic, the nanoplastic plastics. The smaller the size, the more of a concern it is, and we'll talk more about that. The number of microplastics. If you swallow one piece of microplastic that's 1/8 of an inch, you'll excrete it and probably no big deal. But if you swallow 10,000 nanoplastics, that might be a concern depending on what type of plastic it is. So you have the size you need to think about, how many of those, and what type of plastic it's made up of, or a complex or a matrix of different plastics. Some plastics are much more of a concern than others. The next area that we need to think about is contaminants that are attached to the microplastics. For instance, here locally, we have been studying the low levels of pharmaceuticals and naturally occurring estrogens in the wastewater system. When someone washes a synthetic ski jacket and it gives off many microfibers, microplastic fibers, and it's flowing down the sewer system, it is likely to attach to those low levels of pharmaceuticals or estrogens also flowing down the pipe. And we call this a Trojan horse, because now you have a microplastic with something attached to it that isn't particularly to the benefit of the receiving organism or the environment. So it's something that, you know, it's not something most people think about, but these low levels of pharmaceuticals and naturally occurring estrogens readily attached to microplastics. The next one is pathogens on microplastics. If you have a piece of plastic on land blown around and it picks up a pathogen and then it gets blown off into a reservoir that is used for irrigation or drinking water, now that piece of plastic can be swallowed and it may have a pathogen attached to it. And we call this waterborne to dietary uptake. What that really means is, so you have this piece of plastic, and let's just say an estrogen is attached to it. It's in the water, it's floating down the stream, but then a farmer irrigates with that water to irrigate his carrots. Now, especially those nanoplastics, which are really small, are small enough to be taken up by the roots and transported to the vegetable. And now you eat that vegetable, now you have eaten microplastics, which may or may not have an estrogen attached to it. And we call it that dietary uptake. To better understand the impact of plastics, we need to do a little biology lesson here and talk about the endocrine system. The endocrine system is that set of glands in our bodies, and fish and all other animals have the same type of system. And each of these glands excretes a very small amount of hormone into your circulatory system generally. Those low levels of hormones control everything about us. Facial hair, you know, everything about us, how we develop, and it controls our body. When a compound comes along and it disrupts or blocks or mimics the endocrine system, we call those endocrine disrupting compounds. And while this talk isn't about PFAS chemicals for the most part are endocrine disrupting compounds. So what do we know about certain plastics? First of all, the phthalates that are used in some plastics are endocrine disrupting compounds. These are the plasticizers that make plastic pliable. And think of anything you pick up where the piece of plastic is pliable. It'll generally have phthalates in it. It's a chemical that makes them flexible. But there are compounds in this group of phthalates that are not hormones or not estrogens. We call them xenoestrogens, which are synthetic compounds that mimic a true estrogen. and the body thinks it's an estrogen and it responds accordingly. Many of you have heard about bisphenol A. It's a well-known, compound in plastics. It's an endocrine disrupting compound. PVC is one of the most toxic plastics under certain conditions. And the reason for that is PVCs contain a large amount of phthalates, which is, again, that endocrine disrupting compound. So PVC microplastics are of a greater concern than many of the other plastics. And that has a recycle symbol number 3. So what happens when you swallow a microplastic or a nanoplastic? Well, down in the intestinal lining, the epithelial cells can pick up those really small nanoplastics. If it's a piece of plastic, a 1/4 inch, you'll probably pass it and excrete it in your feces, no big deal. But if they're small enough, they can be taken up by the intestines or taken up by the livers and then distributed throughout your body. A few comments about us humans living in a microplastic world. Just about everything we eat, touch, drink has the potential to have microplastics in it. We also have the danger of breathing in microfibers. If you're at home and you're sitting down on your couch and your dog is scratching your couch next to you, microfibers are being kicked up. Most of the time, those fabrics contain plastics of some sort. On the average, it's been shown that humans consume about 100,000 microplastics per year. That's like 250 a day, to put in perspective. Talk about the neurotoxicity impact of certain plastics. Again, the smaller the piece of plastic, the more of a concern it is. If the piece of plastic is small enough, and this is down in the nanoplastic range, it can go through the lining of your intestine, it can go through the lining of your lungs, and it can potentially cross what we call the blood-brain barrier, which very, very few compounds can do. That's a concern. Microplastics in the environment are being studied by many, many organizations and researchers. And we have really good evidence of the impact of microplastics on the environment and aquatic organisms. This problem is getting to be a bigger and bigger problem because more and more plastics are being produced and the number of different types of plastics is constantly increasing. So the problem's getting worse, and the cocktail or the matrix of microplastic pieces, fibers mixing together is becoming more and more complex all the time. What is unknown is exactly what are these microfibers doing to humans. There's a whole list of researchers that are making comments like there's not enough data to say exactly how microplastics are affecting human health. It's very difficult to study. Again, you have all these microplastics of all these different sizes. The potential exposure numbers of fibers varies. The duration varies. The type of plastic varies. And you have all mixtures of everything in between. So it's very hard to really wrap your arms around it, really say for certain that this particular type of plastic under this concentration, for this duration, for this size, and for this number of particles produces XYZ, damage to the human. The other part that is just now really starting to be studied is the uptake of nanoplastics in particular in the food crops. Talk about the carrots and all. But again, the nanoplastics are so small that they can be taken right up through the roots and go through the cell walls of whatever's being grown. So the risk assessment of nanoplastics and microplastics in general in the diet of humans is really unknown. That we don't have an answer for that yet. Yes, ma'am. So the question was, if nanoplastics uptake nanoplastics in the growing season, do those plastics change? A lot of these plastics are very, very resilient. And some of these plastics contain PFAS chemicals, which are exceedingly difficult to break down. So once they're in there, there's not much degradation. Now, there's some exceptions to that, but the PFAS type chemicals that are parts of plastic, and I'll talk about that here a little bit more, we call them forever chemicals because the chemical bonds are really, really strong, and it's really hard to break them down. Yes. Sure. So the question is, can you speak a little bit more about endocrine disrupting compounds? So back when we looked at the endocrine system, all those glands that are in the body, those glands excrete tiny amounts of hormones in our blood, generally. And those hormones control everything about us. Let me give you an example. Here locally, we've been studying the impact of endocrine disrupting compounds on our fish population. And we have been looking at estrogens in particular, natural and synthetic, at very low levels in our local streams. And when we sample the fish population, we can see that the male fish start getting ready to produce eggs, because in the blood of the male fish, we see this protein that's used for egg production. So to answer your question, when you expose a male fish, as an example, to estrogens, that male, through the endocrine system, and because of the endocrine disrupting compounds, thinks he is a female, and he will start physiologically and morphologically changing to a female. There was a study done in Canada where they took a pristine lake and they took the active ingredient in birth control pills and they dosed the lake at 5 parts per trillion. Very, very small amount. They changed the entire male population to females, and the entire population collapsed after a couple of years. Yes. The endocrine is, it's an overlap. So you can have endocrine, let's say the active ingredient in birth control pills has nothing to do with plastic, but it's an endocrine disrupting compound. Plastics, during the manufacture and contained in the plastic and on the plastic, can be similar endocrine disrupting compounds. So some plastics have endocrine disrupting properties to them and some don't. But the ones that I listed with the phthalates, the PVCs, the bisphenol, those all have compounds that act just like the active ingredient in birth control. Sure. Or the liver. They really will pierce any type of cell that uptakes nutrients or air or other substances. Yes. Yes. So the question is, has studies been done to where they've taken samples from either humans or other biota to look and see and determine if those microplastics are taken up? And the answer is yes. So let's change kind of gears here a little bit and talk about wastewater and what we are doing here locally. So across the country, a number of entities are starting to look at microplastics in the wastewater. And we're one of those. So wastewater isn't much different than what you would expect in the ocean, except we don't see the micro rubber fibers because wastewater is flushed down the commode and it doesn't pick up the micro rubber off the road. that all gets washed off into the local streams and does not enter the wastewater system. But microplastics in the wastewater is made up almost, well, 80% from fibers, and I'll talk a little bit about that, and about 17% of fragments. So you're almost at a, almost 98% is coming from clothing and little pieces of plastic that are fragments. A typical load of laundry that contains synthetic clothes has about 700,000 microfibers per wash. Huge quantity. A third of the plastics in the ocean come from laundry. And this is after it's gone through a wastewater treatment plant in most places. Wastewater treatment plants are not required to monitor or remove microplastics. We tend to be a little progressive here, and we want to know what's going on before we're told we have to do something. So we have been studying the estrogens, impact on fish, and microplastics and PFAS compounds. But it's quite fascinating to find that wastewater is a source for most microplastics. So here locally, we took some samples, and with the raw wastewater coming in, what we all flush here, and this includes obviously the laundry water from people washing clothes, we found that there's almost 15,000 particles, microplastic particles per quart of water. Now, Chad over here is in charge of our treatment division, and he's overseeing the treatment of about 5 million gallons of water for today. We got a fair number of people in town, tourists skiing and all. So out of the 5 million gallons, if you go through the math, we are receiving about 3.2 million microplastic particles per second for the day. 3.2 million microfibers or microplastic particles, however you want to say it, per second. What we receive at the treatment plant. Now, fortunately, we have some advanced treatment here, even though it was never really designed to remove plastics. We removed the plastics from about 15,000 particles per quart down to about 1,000. This is particles greater than 10 microns. We have not sampled down in a nano plastic range because that gets to be really, really difficult for us to do that. The types of plastics we pick up, this is just a whole list of different things we pick up, all kinds of things. One of the things we do pick up is PVC. PVC is used in a lot of applications, including clothing. And you can see that we picked up more PVC than anything else. This is unfortunate because PVC is one of those plastics that we'd really rather not see. We picked up another plastic called polyamide, which is also used in clothing. That was the second largest quantity we picked up. And we picked up some polyesters, again, used in textiles and apparel. And we also picked up some compounds that coexist. You talked about the PFAS compounds and the microplastics. A good example is Gore-Tex. Gore-Tex is made up of a type of plastic, and it has coatings on it that are made out of PFAS chemicals. Now, Gore-Tex, Patagonia, Hansen, and others are trying to get away from the PFAS chemicals, and they've made a couple pieces of clothing without these compounds, and they failed. So they're really trying to find an alternative, but the products are not performing as well as they would like, so they're still using PFAS. Now, Gore-Tex just announced that their outer, or is it the inner layer? I think it's the inner layer is now PFAS free, but the outer layer still has PFAS chemicals in it. And that's something that me personally feel like we really need to avoid. PFAS, that's per polyfluorinated acryl compounds. There's over 5,000 of them. So they're used everything, everywhere. They're using sunscreen, you name it, you got some type of PFAS chemicals in there, and most commonly they coexist with microplastics. On the treatment side of things, we used advanced treatment, or tertiary treatment as we call it, and our crews do a very good job. We're up and around the 99% range of removing microplastics. These are some percentages. One sample we removed about 93%. The other one we're around about 100%. Again, these are the true microplastic range from the 5 millimeter down to a little above a micron. When microplastics are removed from wastewater, it ends up in our solids. We call those biosolids. Many places in the country, biosolids are used on land application areas. We think that's a bad idea. We will not be doing that. But here in Utah, wastewater sludge is used in many, many places, and we think that contributes to microplastics in the environment. Again, the wastewater industry currently is not required to sample, research, look at, report, or have anything to do with microplastics. Now, in the future, that'll change, we think. It'll change first with the PFAS chemicals starting next year. But right now, there are no requirements to do any kind of monitoring whatsoever. So how can you curtail your use of microplastics? Well, one, drink water out of the tap instead of a bottle of water. A bottle of water has about twice as many microplastics as tap water. And the next one is, do not heat up food in a plastic container. Doesn't make any difference what kind of plastic it is. Now, there are some exceptions. I'll touch on that. But when you heat up plastic, it releases those phthalates and those endocrine disrupting compounds. You should really avoid it. Put the food in a glass container. Try to avoid, especially avoid the plastics 3 with a recycle code 3, which is PVC, and 6 and 7. Because they contain those phthalates and other compounds. So again, try to avoid using plastics that have a recycle symbol of 3, 6, and 7, especially 3. It's surprising how many microfibers are floating around your house in the form of dust. And one way you can help control that is run a really high efficiency furnace filter. Get the ones that I think it's rated out of 10, and they really do a great job. They're not cheap, but they'll help remove some of the microfibers floating around your house. I had a question the other day, Mike, how do you handle your food? Well, I do have a food grade vacuum seal system that I use that uses a low density polyethylene bag. Those are the kind that you'll often see sold at the store that you can cook a turkey in and seal for freezing meat and things. I would not microwave food in those types of bags or any kind of bag because that really heats up the plastic. And generally the polyethylene is considered a safe plastic and has lower levels of phthalates, if any at all, and it's considered a safe plastic. So not all plastics are created equal. Certainly the ones with a recycle symbol, the 3, 6, and 7 are the ones you really need to avoid. So at this point, I'll leave it at that and answer any of the questions that you may have. Yes, ma'am.
So just storing food in a plastic in the refrigerator, does that?
If it's cold, it's better than hot, okay? And cool the food down before you put it in a plastic container. And duration also has a little bit of something to do with this. If the food is acidic and it's sitting in a plastic container for a very long time, that's a higher risk than if it's more of a neutral food and not sitting there for 2 weeks. So it's all levels of risk. It's not a yes or no situation. So I do store food in plastic containers, but I always make sure the food is cool. I make sure that it's not a container of 3, 6, or 7, and it's not acidic.
I'm curious to understand your interest in Snyderville Basin's parent project in regards to this. It's not required for the reclamation district to do this, correct?
That's correct.
Are you involved in research? Is there grant money that helps you study this? How does it motivate you?
Okay, well, this is our motivation. Our job is to protect human health and protect the environment. I didn't say our job is to protect human health and environment if we're told to do so by some regulatory agency. So we understand that we discharge into some very small mountain streams with sensitive species, mainly the Bonneville cutthroat trout as an example. So some 13 years ago, we started to do some research on the fish with the estrogens. And we teamed up with Baylor University and an engineering firm, and jointly the three of us have performed that research. A number of papers were published in scientific journals, and it's helped us understand at what level will we here at the district need to take action to protect the local fish population. We have spent, and the citizens of this community have spent tens of millions of dollars building these advanced treatment plants to clean up what we call conventional pollutants. And it makes no sense whatsoever to spend all that money, protect them, and then turn them all into females and for the fish population to collapse because we have too much estrogen and it's not regulated. So that's how we got started with this. Microplastics is along the same lines. We want to know if we are currently causing or have a potential to cause damage to the environment. So we're conducting the studies, the research, some of which, again, is published in research journals. And we have determined that on the pharmaceuticals and the estrogens, that with the current growth taking place in the Park City area, that there will be a tipping point. And we know where this is mathematically based on samples, that at some point in time, we will need to install additional treatment to protect the local fish population. And on microplastics, we're looking at ways to improve that as well. Ironically enough, there are some manufacturers that are making filters to tag on the washing machines. You know, you kind of get this little screen on your dryer that catches the lint. A very fine filter is something that you could currently purchase and put on your washing machine that would catch microplastics. We don't think everybody would do that. We think it's better for us to do it on a large scale wholesale efforts here at the treatment plants. And we are already removing well into the on the average, about 94%. And if we need to remove the rest of it or a little bit more so that we don't have a problem, we think we can do that. So on the microplastic side of things, to kind of sum it up, on the microplastic side, we're already doing a pretty good job. You know, on the estrogen side, our plants remove very little of the endocrine disrupting compounds, and we think that we will have to install some type of additional treatment in the future.
How much does that cost, the additional technology to do that?
To remove endocrine disrupting compounds in pharmaceuticals, you take an approach whereby we know what kind of pharmaceuticals are now used. We know that new pharmaceuticals are being developed and sold every day. So we basically have to remove all of them. And the way we would do that is we would use a combination of ozone, which is type of oxygen that oxidizes these big organic molecules, it breaks them down. We would put in a biofilter, and we would also use granular activated carbon, kind of like you use in the back of an aquarium, to capture the PFAS chemicals. So we would remove it all. And it would add probably about $5 to $10 a month on the average sewer bill. Yes, sir.
There you go. Thank you.
Would my RO filter at home be effective in removing out of my tap water?
Yes. Yes. If you have an RO filter and it's properly maintained, it'll take care of any microplastics that are in your drinking water.
And I wondered, what do you do with your biosolids where yours currently end up?
Currently, we truck off anywhere from 1 to 3 dump trucks of biosolids a day. They currently go down to the Salt Lake landfill, and they use it to grow grass and use it for top cover, Because we have an advanced plant, we remove the nutrients, the phosphorus and the nitrogen out of the water, and they like to grow grass with that. So it's put to beneficial use by helping the landfill out by covering their stuff up. We would like to send our biosolids to an anaerobic digester to produce natural, green gas, green natural gas as we call it. Unfortunately, our partners down in Salt Lake are having some issues with their anaerobic digester, and they haven't given us a green light yet to take it down there. But we struck up more or less a contract with them a couple years ago, to do that. They just haven't been able to produce that yet. I want to add one thing about our local situation. You know, East Canyon Creek at one time was a blue ribbon trout fishery back in the 80s. It had plenty of flow in it all year long. Unfortunately, we all moved here. We all needed water. So the water was taken out of the creek and we all used that water. So during the dry summer months, above where we discharge our treated wastewater into the creek is either dry or the flow is very, very, very low. So the water that we put out, which is your wastewater, my wastewater that we treat, has to be of a sufficient quality to support those Bonneville cutthroat trout and not turn them all into females. So that's somewhat of a harbinger of things to come for other locations. But up here, you know, we've used all of our water, and the wastewater, once we treat it, is now used to protect our local environment because it's of that quality.
Question from online, but I do want to say one thing about East Canyon Creek. Some of that upstream area is on the Swan River Preserve. So we definitely see the impacts of that and appreciate all that you do to keep the fish populations going. Shira wanted to know what an RO filter is.
Reverse osmosis. Yes.
Cool. And then I have some questions for you. Let me see. Oh, what about, so at the end you were talking about food storage and plastics. What about silicone? Or does that fall into?
Silicone is a type of plastic, but it's not carbon based like most other plastics. It's silica based. Certain silicones can be a problem too. I would not heat food up in a silicone type container. So the same thing goes there. Follow the same general rules to reduce your exposure, but silicone is a type of plastic. It just chemically, it's a little bit of an oddball.
That makes sense. Cool. And then I was just curious, how did you measure the particles that were coming in, and how are you filtering them out? Okay. What is the process for that?
We are working with the university down in Arizona through Carrillo Engineers, who's been a great partner of ours. And they have some very specialized laboratory equipment to do that. That is far beyond our capabilities here. And matter of fact, some of the equipment that the University of Arizona has is very specialized, and there's only very few of them in the United States.
At the plant.
Oh, we just run well, we don't filter, we just collect a sample and then they take it from there.
Okay. Yeah. Oh yeah, your removal. How are you removing it? Sorry.
So here at the treatment plant, we filter out all the beer cans and the kids' toys through a screen that's like 6 millimeters wide. Okay. Doesn't do any treatment, just captures all the big stuff. Then we run what I like to refer to as a farming operation, because our treatment plant is made up of millions and millions and millions of living microscopic organisms, and we feed those microscopic organisms the organic material that we all excrete, the wastewater. So we convert wastewater, or the organic material in wastewater, to living organisms. And we settle out those living organisms, and that's what we truck off. Once we've gone through that process, then we want to remove more of the nutrients, phosphorus in particular. And we go through a process where we add a polymer, which is kind of a sticky substance. And anything that's in the water sticks to that. And then we run it through like 12 feet of sand, real fine sand. And that takes that everything that's stuck together out. So that's how we capture it in the first phase. When all these microorganisms settle, they capture some of it, and then we filter out the rest through the sand. And This sand, the sand filter is what we call a continuous backwash system. You really have to see it to work. It's quite amazing, where we're constantly rotating the sand, cleaning it, but it's also filtering the wastewater all at the same time. And to answer your question, yes, we do have to add some to it. And if something strange happens, say someone dumps something down the sewer system in large quantities, it stops up that sand, then we got to put all new sand in. But if everything goes well, we don't have to do that very often. And again, we invite people to take a tour. We can show them these filters in operation and get a good idea how the wastewater is treated.
If you have a chance to come and take a tour from them, it is totally worth it. It seems like it might be gross, but it's actually very, very cool.
And if any of you would like a presentation on the work that we've done on the pharmaceuticals and the estrogens and the fish studies that we've done, we'll be happy to spend some time with you and go over that. I just gave a presentation on that exact same thing to a group down in southern Utah last week.
Awesome. Do you have any more questions? All right. I think we're all good. Thank you so much, everyone, for joining us. For those of you who are in person, we can take a quick tour with Mike if you're interested. And then thank you, everyone, for joining us online. If you're interested in any more walks, talks, and workshops, just head to our website and see what's coming up. Thank you.
Thank you.